Okay, so today we want to welcome you to my lecture as we're going to be focusing on weighted voting systems. Of course, we started chapter 10 last week, and of course, we're going to finish chapter 10 today. And of course, when we're meeting on Monday, our meeting on Monday is actually going to be on the final practice. Okay, because we're going to have exam December 9. I'm actually going to post exam question 8 a.m. in the morning on December 9. And of course, it's going to be on for 24 hours. Of course, you are expected to have your submission latest 11:59 p.m. on December 10th. Oh, sorry. Not 11:59 p.m. December 10th. I mean, if I post it at 8 a.m. December 9, then I'm expecting that 8 a.m. December 10. So it's going to be on for 24 hours. Okay, so like I said, I'm going to be walking you through weighted voting system today. And of course, the objective today is actually going to be on understand weighted voting system using um, you know, I don't know whether you guys have heard about collation, you've heard about proposal. Okay, can you guys confirm if you guys are hearing me? I think I have a chat right now that said I freaks.
Yeah, we can hear you. You just
Oh, you
froze
can.
for a
Oh,
second.
okay. Thank you for confirming that. Okay, so like I said, if you today you actually, I'm actually going to walk you through how uh, what operates in the weighted voting system. And of course, the United States of America actually practice a weighted voting system. And you're going to know the activity, what it takes to pass a bill uh, in the national, I mean, in the Congress. Yeah, somebody said, give me 1 second. Somebody said, I can't hardly hear him at all. Going in, going out. Uh, okay, as I'm talking now, if you're not hearing me, I want you to say if you're not hearing me clearly. Is everyone? Oh, okay. The person said it might be my head, maybe a headphone. But if you're hearing me clearly, I need you to say yes. You're hearing me. You hearing me, everyone? Oh, okay. Some, yeah. I think I've seen. I can hear you. Okay, so maybe that person needs to adjust the headphone. I'm so sorry about that. Because I want everyone to be hearing me clearly. Okay, so like I said, that is the objective. Now, weighted voting system. You know, in the last section, I walk you through how election work in the United States of America. I told you what we called, the electoral college. United States use electoral college system where every state has, different number of electoral college votes. Of course, the state of California has 55. The state of Texas has 38, and the Minnesota has 10. Okay, so you're actually going to understand today in this lecture how different states have different electoral college votes. Okay, and of course, uh, the population sizes, of course, is actually the primary way the United States House of Representatives and the electoral college based voting power. Okay, which is an example of a weighted voting system. Now, when you talk about weighted voting system, what do we mean by that? Okay. Now, it's a system where an individual voter may have more than one vote and thus more power than another voter. Now, I told you something the other time that if you want to go by population, in the United States of America, the state of California actually have the highest population, and of course, the state of Wyoming have the lowest population. But do you know that if one person votes in the state of California, okay, that may be I mean, if one person votes in the state of Wyoming, that may be equivalent to 3% votes in the state of California, because they have to adjust that in a way, because if they don't do that, it means California will always have their way. Okay, and that is the reason why they are actually introducing, under the weighted voting system, of course, a particular voter, you know, actually have more power than another voter. So what I'm trying to talk about now, a voter in state of Minnesota does not have a power compared to another state. Okay, so under a weighted voting system, then all citizen does not have equal votes. Okay, there's a particular voter that have more than one vote than others. Okay, that's what we mean by that. Okay, now uh, I'm going to walk you through how the weighted voting system work. Okay, we're going to consider some players. Uh, those who vote, we're going to be referring to them as players. Okay, they are players because they could vote for this, they could vote for a candidate A, or they may decide to vote for a different candidate. Okay, so because of that, I'm actually going to call a person casting a vote a player. Okay, now in a situation where I have n number of players, okay, where I'm actually going to have from P1, give me 1 second, for P1, P2 up to Pn, if that actually represents the symbolic representation of each player. And when I talk about player, I mean somebody who casts a vote. Okay, now each of these actually have a weight. Each player has a weight. Okay, take a look at that now. Player one, which is P1, has a weight W1. Okay, player two, uh, which is give me 1 second. Okay, now player two, which is P2, has a weight W2. Okay, so and up to player PN as a weight WN. So which means under a weighted voting system, we actually expect you know players, the voters, to have different weights. Okay, now uh, we refer to that, so which means, you know, every player actually have a weight. And don't forget, N is the number of players, I mean the number of voters, and WI actually the number of vote that player I control. So what I'm trying to tell you now, every player has a good number of votes they control. And therefore, a particular player may have more votes than another player. Okay, now, there's something that we call a quota. Okay, that's what we call a quota. Okay, Q, and that is the minimum number of votes needed to pass a proposal. I'm actually, in the House of um, Senate, in the United States House of Senate, of course, there's a minimum number of votes needed to actually pass a bill. Okay, so of course I'm actually going to walk you through that right now. So which means in any weighted voting system, we're actually going to have this kind of notation. Okay, well, what does that mean? The notation actually represent, what does Q represent? The Q represent, the minimum number of votes required to pass a proposal. Okay, maybe there's a proposal. Let me tell you, what we're doing today is more or less you know political mathematics. Okay, this is a political mathematics. This is applying mathematics to election matter. Okay, that's what we're doing now. Okay, now like I said, what I circle right now actually is a symbolic representation of a weighted voting system. Okay, Q right here is actually the minimum number of votes required to pass a proposal, and of course, from the W1 up to WN are the weights. Okay, at the number of votes. Okay, for different kind of players. Okay, W1 is the number of votes a player won, a voter one actually control. W2 is a number of votes a player two actually control. Okay, when I talk about players right here, I may be talking about you know, representative, probably people in the House, okay, people in the Congress, okay. Now, the next thing I actually want to talk about, let's go into an example right now, okay. And this example is actually going to center on the weighted voting system, okay. Now, a voting system has four players, okay. We got a Jane, we got a Marilyn, we got a Kent and Stan. Jane has 4 votes, Marilyn has 3 votes, Ken has 2 votes, and Stan has 1 vote. Take a look at that. Each of these uh, players actually have different number of votes at their disposal. Okay, and you know what? A majority of 6 votes is needed to pass a proposal. Okay, now use the notation for weighted voting system to represent this voting system. Okay, now what you just need to do, you just need to identify what is going to be your Q, what is going to be W1 up to W4. And of course, you remember the other time that I said using a notation where I got a Q, which is a minimum number of votes required to pass a proposal, and the W1, the W2, the W3, the W4 this time around because we have 4 players. Okay, therefore, look at that. That is the answer. Look at that. Q equal to 6, W1 equal to 4, W2 equal to 3, W3 equal to 2, and W4 equal to 1. Take a look at that. That is how that is represented. Okay, is there anyone who want to ask question? Is there anyone who need clarification on that? Okay, if you guys get that clearly, can you say yes if you get that clearly? Okay, good job. Thank you for responding. I think it's only one person that responded now. I want to know if you guys are getting it clearly. Uh, but if you don't get it, I'm actually going to re-explain. Okay, making second. I think I have the second person say yes now. Okay, so that means you guys are good. Okay, now I'm going to go to a dictator now. You know, what do we mean by dictator? A dictator is a player with power to pass a proposal single-handedly. That is, the dictator has at least as many votes as the quota. You know, take a look at this. We know the minimum number of votes required to pass a proposal. Okay, if one of the players actually have that minimum number of votes, then I mean to pass a proposal, then that person is a dictator. Okay, it's actually a dictator. Okay, so that is what we mean by a dictator. Okay, now let's go to veto power. I know in politics you've heard about veto power. Of course, we have seen presidents, who have used veto power most of the time to veto a bill. Situation whereby maybe um, there is a high gap, in terms of agreement between two major political parties in the U.S. Congress. Of course, the president of the day could actually use a veto power. Okay. Now, what does it take? What do we mean by veto power? A player actually have a veto power in a voting system when they can keep a proposal from passing with their votes, but do not have a majority of the votes. Okay. This is actually different from a dictator. A dictator has the what it takes to the minimum number of votes to pass a bill single-handedly. But you know what? A veto power, a player that has a veto power does not have that, but only that this guy actually can keep a proposal from passing with their vote, but do not have a majority of the votes. Okay, do not have the majority of the votes. Okay, now there's another thing, one that we call a dummy player. Look at the word dummy. Okay, so it's a player that do not have enough votes to have an effect on the outcome of a proposal. So which means you don't necessarily need that kind of person in your coalition to win, to secure a proposal. Okay, because he's he doesn't have enough, he doesn't have what it takes. Okay, so therefore that kind of person is actually going to be a dummy player. Okay, so in a weighted voting system, of course, we could have a player with a veto power, a player with a dummy player, and at the same time, we could also have a dictator. Okay, so take note of that. Now, what do we mean by collation? Of course, that is from when a group of players decide to vote together. Okay, it's just like what is happening now. I was listening to a cable news network yesterday, and I saw a proposal by one of the uh, congressmen, particularly I think a senator from probably West Virginia, that initiated, you know, a bipartisan, move on the palliative package. Okay, so that's a collation because the moment they agree, of course, when that is actually brought to the floor of U.S., to the floor of the House or to the floor of the Congress, of course, they're actually going to vote together because they have agreed. They form a coalition. Okay, and of course, uh, what is required in the U.S. Senate, in the U.S. Congress, is because there are two major political party. I think what is required is they need a coalition, they need a bipartisan agreement, okay, before a bills can actually, be passed. Okay, so that's what we mean by coalition. Okay, they come together and they decide to vote together. Okay, they work on a common goal. Okay, now there's something that we call simple majority. What do we mean by simple majority? Okay, we could have a situation whereby some proposal require more than half of the total vote to pass. So, which means more than 50%. Okay, more than 50%. Look at what happened. The electoral college votes in the United States, the total number of them is 538. Okay. Now, in a presidential election, a candidate that have more than half of that, of course, the half of this is 269. So at least more than half is actually going to be 270. So that is what we mean by simple majority. Okay, so by simple majority, we actually mean that we have some proposal that may require have more than half of the total vote to pass. Okay, now the next thing that I want to talk about is super majority. Okay, the super majority is actually different from simple majority. It's not just more than half; it has to be two-thirds. I could remember in 2018, there was a government shutdown in the United States of America because, you know, a bill, was not able to pass in the House because of the fact that, that particular bill, according to the U.S. Constitution, actually required supermajority. Okay, it actually required supermajority number of votes to pass. Okay, and then because of that, the government was not able to have they were not able to avert a government shutdown. Okay, in 2018. Okay, that actually happened. So at times, you know even if presently the number of Republican in the House is, this in the House of Senate, in the U.S. Senate is actually more than the Democrats senators. But you know what? Some bills that required supermajority may not be passed if um, the two party are divided. Okay, because the only way it can be passed if is when the two-third. Okay, when you're talking about two-third, if we have 100 senators in the Senate, of course it means two-third is actually going to be, I think, about let me look at my calculator. Okay, um that would be about 60 something percent. More than that would be 60 something percent. Okay, so which means the 60 something percent of the Senate, okay, of the senators actually have to, vote in that, and I mean, have to cast a vote that will support that proposal. Can you guys confirm if you guys are still hearing me clearly? Okay, thanks for confirming that. Now you know the difference between simple majority and super majority. Okay, and let me tell you this, it is not all the time, that depends on the bill. In the Senate floor, in the House of Representative, the Senate floor, depending on we have different bills that actually, there are some bills, before they could be passed, there's some bill that may require super majority, there's some bill that may require simple majority. You get what I mean? Okay. Now, the next thing that I'm actually want to talk about now, let us now go into an example. Okay. Now, passing a motion with a coalition. Okay. Probably there's a motion before the House. Okay. And given the voting system, take a look at this voting system. Okay. What does 18 implies? 18 is a queue. Remember the formula in a weighted voting system? You remember the formula W1, okay, W2, dot 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 until you get WN. Okay, you remember that formula. Okay, Q is actually the minimum number of votes required to pass a bill, to pass that motion. Okay, and you know what? How many players do we have? If you take a look at what I have right here, 1, 2, 3, 4, 5, 6, 7. Okay, we got 7 players, and that is their weight. Okay, that is the number of votes per players. Okay, now player one has 8 votes, player two 7 votes, player three 6 votes, player four 4 votes, and so on like that. Take a look at that, and they say determine if a motion will pass, if a coalition consisting of players 3, 4, 5, and 6 votes in favor of the motion. Now, when you talk about, now let me name them. This is player 1, this is player 2, this is player 3, player 4, player 5, player 6, player 7. Okay. Now, our player 3, 4, 5, and 6. Okay. Now, let us add what they have together. That will be going to be 6, okay, plus 4, plus 4, okay, we 4 and plus 4, okay, so player 3, this is 3, 4, 5, and 6, okay, so we want to add all of that together. Okay, when you do that, we actually want to see whether they're going to make up to the minimum 18. Of course, look at that, that's exactly what we're trying to do right here. Okay, we added that together. So if those players actually come together, okay, if they form a coalition with the votes that they have, of course, or they can actually reach up to the minimum number of votes required. Take a look at that. So with a quota of 18, that was why I said with a quota of 18, the 4 players will have enough for a simple majority. Okay, that is, why do I say simple majority? Because if you want to add, let us add all the votes right here together. Okay, let us add all the votes for the players. We're actually going to have 35. Okay, what is the half of 35? The half of 35 is actually 17. Let me see. Yep, 17.5. Okay, so that's going to, and 18 is more than the half. That's a simple majority. Take a look at that. And that's why I said, so 18 is a simple majority, which is more than half of the total votes. Take a look at that. Okay, so therefore, the players, they will be able to secure the motion to pass. Take a look at that. Okay, um, you can actually work out on that one with a quota of 18 being a simple majority. How many votes will be needed to pass in a super majority of 2/3 of the votes in the voting system, for example, 2? Of course, if you want to do that, you actually need to do 2/3. 2/3 of what? Of 35, which is going to be 70 divided by 3. Okay, so when you do 70 divided by 3, of course, you're actually going to get something close to that. Look at that. That's what you're going to do. Okay, that's what you're going to do. Okay, now, uh, before I move on to the critical player, is there anyone who want to ask question or who need clarification? Is there anyone? Can you guys confirm if you guys are hearing me clearly? Okay, thank you so much. Okay, now the next thing that we want to talk about now is critical player. What does it take a player to be critical in a coalition? Okay, so a critical player is a player with a veto power. Of course, you know what I mean by veto power. With the veto power, that particular player is critical because it has, a good number of votes at his or her disposal. Okay. Now, the next thing, let's take a look at this. Consider the voting system, with this. Okay, where the minimum number of votes required to win a coalition is 10. And of course, we got 5 players with different number of votes at their disposal. Player 1 has 7 votes, player 2 has 6 votes, player 3 has 3 votes, and so on like that. Take a look at that. Now, determine a winning coalition and identify any critical players in each coalition. Do you know, in your final exam, I can actually give you a question like this, and I ask you to determine a winning coalition and also ask you to identify if there is a critical players. And let me tell you something, there's possibility we could have a critical player, we could have a dictator. Okay, I can ask you to identify if there's a player, if there's a dictator. Okay, of course, a dictator is actually going to be the one that we have the minimum number of votes required to pass a bill. But what I'm trying to see, what I'm seeing right now, there's no dictator among these players because none of them can single-handedly, okay, none of them can single-handedly, achieve the minimum number of votes required to pass, to win this coalition. Take a look at that. Okay, now how do I determine the winning coalition? Determining a winning coalition is just trying to look at the possible combination of players that can actually give us the minimum number of, the minimum 10 required. Okay, so we're going to look at the possibility. Okay, now there are going to be several of that. So the very first thing you're actually going to do, let us first write out the players and let's look at the number of votes at their disposal. Okay, now of course, we are actually, none of them, the way they stand, there's no number here that's up to 10. That's what I mean. There's no number here. Okay. Which means we don't have a dictator right here. Okay. There's no dictator right here. So which means you will need a coalition. Okay. At least 2 people have to come together. Okay. Now let's now consider possibility. Oh my God, there's a lot of possibility. It's either P1 and P2 come together, P1 and P3 come together, and so on like that. That is a possibility. And when you take a look at that, you're going to start from 2 combination. Take a look at that. From there, you're going to move to possible 3. Okay, these are possible 3. And when you are done with the possible 3, you're going to go to possible 4. This is a possible 4. Can you see the possible 4 now? And we are done with that. Then you're going to go to the last possible 5. Okay. Now, when you take a look at each of these correlation, that will give us at least 10. Okay. Take a look at that. There are several possibilities. Take a look at that this can occur. Okay. Now, but if looking at this, how can we identify a critical player? Okay. A critical player, if I remove that player, that player have to dominate. Okay, a critical player should be the one that can actually dominate. And you know what? If you take a look at this guy and this guy here, they have a good number of votes. Do you know that those 2 guys can actually decide, the coalition, the P1 and P2? And you can actually find the P1 and P2 in most of the coalition. Take a look at that. There's a P1 and P2 here. There's a P1 here. There's a P1 here. There's a P2 here. There's a P2 here. There's a P2 here. There's a P1 here. There's a P1 here. There's a P1 here. There's a P1 and P2 here. P1 and P2 here. P1 and P2. P1 and P2. Take a look at that. In every of the possible coalition, you can have a P1 and P2. I'm not saying that you're going to have the combination of P1 and P2, but what I'm trying to say, we're trying to figure out where we can have a P1 and where we can also have P2. Take a look at that. And therefore, P1 are P2. And that was why I said you might notice that there are 2 players where one or the other must appear in a coalition in order to create a majority. So P1 and P2. So these players are considered critical players. Okay. And another thing is that if I remove them, let us remove them. Now look at the other three players. When you add whatever vote they have, will that give us 10? No way. Okay, even if the other three players should come together, they're going to give us 7. Okay, if you add all this together, the highest they can give is 7. Okay, take a look at that. Okay, and that was the reason why I'm actually referring to P1 and P2 as the critical players. Okay, so therefore, without their votes, okay, the proposal will not pass for any winning coalition. Okay, and that is the reason why other players have to make sure they engage in conversation with these two critical players before a coalition can be can be passed, before a proposal can be passed. Okay, does that make sense to everyone now? Okay, so this is a skills check. You can try that. Okay, so determine if player 4 is a critical player. Okay, and of course is yes. Now, why is it that players fall? Why is it that, they want you to determine with this collation right here, with this collation, that's what they're trying to tell you. With this particular collation right here, is player 4 a critical player? Now, let us take a look. Player 1 has how many votes? 10. Player 2 has how many votes? 9 votes. Okay. Player 4 has how many votes? 8. 8 votes. Okay, so which means without player 4, okay, the addition of what player 1 and player 2 is going to give is going to be 19, and 19 is not 19 that this is going to give is actually less than 27. Don't forget, 27 is a minimum number of votes required to pass a proposal. So therefore, if you have a collation of P1 and P2, P4, okay, of course, if you exclude player 4, of course, you are not going to actually achieve the minimum votes required. Okay, that is that. That's how to go about that. Okay, the next thing now, the next objective of the day, we actually want to talk about Banzhaf Power Index. The Banzhaf Power Index is actually an appropriate mathematical tool, okay, to determine winning collation. And of course, we can actually evaluate how important a player is, okay, with this. And these are the steps. Number 1, we find all winning collation for the system. Number 2, we determine the critical voters for each winning system. Okay. Number 3, we determine how many times each player is critical. Okay, so let me tell you how many times each player is critical is what we call a Banzhaf power. Okay, you have a Banzhaf power if you are critical in a good number of times. Okay, then we determine the total number of times all players all together are critical, and that's what we call a total Banzhaf power. And after that, we're actually going to determine the BPI for player P. Okay. Now, if you want to determine that, we're going to use this formula right here, which is actually the ratio of the number of times player P is a critical divided by the total number of times all players are critical. Then I'm going to multiply that by 100. Okay. So, what we're trying to do right here, we actually want to evaluate, we want to know how critical is a player, okay? Whether, because let me tell you something, we know that all human beings, we're claiming equality, according to Animal Farm, all animals are the same, but some are more equal than others, okay? According to John Powell. Okay, some are more equal than others, though all animals are equal. Okay, okay. Now let us take a look at this. Let's have an example right now. You know, for you to be able to understand, a Banzhaf power index, you need to be able to understand what we've done before. How do we figure out the critical player, stuff like that? You need to, because the idea of that will actually be put into consideration. Okay, now take a look at that. You are winning, you are giving this weighted voting system where We got how many players do we have? We got 6 players with different number of votes. And of course, the minimum number of votes required to pass, collation to pass a bill is 16. Okay, take a look at that. And of course, you can be given a question like this, and we are asked you to find, Banzhaf Power Index. How do we go about that? Okay, so this is what you're going to do. Step number 1, find all winning collision for the system. So winning collision for the system is just like what is a combination of players that can actually give at least 16. That's what I'm going to do first. Oh my God, take a look at that. You know, the winning collision, combining players together that will give at least 16 is this. Take a look at that. Okay. So that is a winning collisions. Okay. There are different kind of winning collision that can actually give us 16. These are possibility. Okay. And this also is also extended to this. Look at that. There are good number of them. Okay. There are good number of them. Okay. Now, after considering the possibility, okay, don't forget what I put in front of them is the total number of votes, by adding whatever the number of votes those players actually have. Okay. Excuse me. Okay. So the next thing I'm actually going to do is I'm going to determine critical players. Okay. In each of the collation. Okay. That's going to be the step 2. Okay. I've given you collation right now. The different kind of them. Excuse me. So there are different kind of them. And the next thing that we're actually going to do, uh, we want to identify in each of the collation, we actually want to identify critical players. Okay. Now, if you take a look at this collation, for example, all the players there are critical. They are critical in the sense that if you remove any, let me tell you this situation where you have 16, where the total number of votes is 16. Because don't forget, the minimum number of votes required is 16 to pass a bill, right, in the House. Okay, if in a particular house or in this particular coalition, I mean in this particular weighted voting system that I'm giving you right now. Okay, now if everybody added up to that minimum, then all players in that coalition are critical. Okay, take a look at that. 16, 16, 16. Then all players, look at that. All players in that collation are critical. Because if you remove any of the player, you are not going to get up to the minimum. Okay, take a look at that. But if you look at others where you have more than 16 require, okay, where you have more than 16 require, of course, there's possibility that, you know, all of them may not be critical. Okay, now take a look at this guy here. uh all of them are still critical because if you remove any one, you are not going to have the total number of the outstanding one will not be up to 16. And that is the reason why all the three players there are still critical. Let me tell you this. A particular player is critical when you remove him from the collation if the votes of others did not add up to the minimum number of votes required. Then that particular player that you exclude from the group is critical. Okay, now so take a look at that. So you're going to do that to every other collation. Okay, so that is exactly what we have done. We have been able to identify critical players. Now, there are situations whereby there's possibility that in a particular collation, you may not have a critical player because in a situation where there are lots, take a look at this guy here. Take a look at this guy here. This is 25. They all give total number of votes. They all give 25. If I exclude anyone, okay, if I remove any of the player, I'm still going to have the required minimum or 16 required number of votes. Okay, therefore, none of the players in this collation is critical. Don't forget there are many. Okay, Because if a lot of people agree on something, okay, if a lot of people agree on something, then hardly will you find one person among them that is going to be that will be critical. Okay, so and the same thing also applicable to this guy here. Take a look at that. But when you take a look at this guy here, okay, take a look at this guy here. Of course, if you remove P1, if you remove any other players, maybe P2, P3, P5, P6, you are still going to have the minimum 16 required. But if you remove player one, okay, you are not likely to have the minimum or required. Okay, take a look at that. Okay, so step two now in the Banzhaf Power Index, we've been able to identify we've been able to identify the critical players. Now, after identify critical player, the next thing we're actually going to do, we're going to have a table where we want to determine how many times each player is critical. We're going to start with player one. Player one is P1, don't forget. Player two is P2, or P3, P4, P5, P6. Now, you're going to go back to the collation. Okay, how many times does P1 appear to be critical? You're going to count that. Okay, 1, 2, 3, okay, 4, 5, 6, 7, 8. Look at that. You start counting, So when you count the number of time a particular player is critical, that's exactly what we're recording right here. Take a look at that. That's what we're recording. Okay, we're trying to record how many times does a particular player declared critical in any of the collation, that I mean in all the collation we have considered. Take a look at that. So that's going to be step three. Okay, and after that, the next thing we're actually going to do, we need to add all, you need to determine the total number of times all players are critical. Okay, and if you want to do that, you're actually going to add this guy together here. Take a look at that. You're going to add that guy together. Okay, so when you do that, that will actually give you 52. Okay, that's going to be step four. Now, the next thing you're actually going to do after getting the step four, the next thing you can actually proceed to get your BPI, okay, using the formula right here, which is so if you want to find a BPI now, you are finding a BPI for a particular player. So which means we're going to get our BPI for the 6 players. Okay. And of course, if I want to find the BPI for player one, it's actually going to be how many times does a player one, deem as critical, then divided by the total number of times all players are critical. When I do that, take a look at that. That's how I'm doing right here. Okay. Calculating for player one. Okay. The player one is going to be 20 divided by 52. That will give me that multiplied by 100. I'm actually going to have this percentage for each of the player. Now, as you can see right here, player one is the one that is most critical. Take a look at that. Look at the percentage contribution of this particular player right here. Okay, is there anyone who need more clarification on what I just explained right now? Is there anyone? Uh, does that mean you guys understand what I just explained now? If you understand, I need to comment yes. Oh, okay, good job. Okay, okay. So the next thing that I'm actually going to do. So, like I said, in other words, player one control about 38.46% of the power to sway the outcome of the votes. That's what that is. That's what we just computed right now. Okay, the next thing that I want to talk about today is what we call sequential collation. And of course, a sequential collation is a collation where the order in which player cast their votes is important. Okay, we're actually going to consider order here. Okay, we're going to consider order right here. Okay, now a pivotal player is a player in a collation whose additional vote causes the collation to reach the quota and made their collation win. Okay, now that is the definition. I'm actually going to walk you through how to figure out that in an example right now. Now take a look at this example. Now recall the voting system from example 4, okay, that we use, where 16 minimum number of votes is required to pass a vote, okay? And of course, we have how many players? We got 6 players. Now, which player is a pivotal player in the sequential collation? Okay, we want to know. Okay, now which player is sequential? Okay, now the very first thing you actually gonna do right now, okay, you're gonna write the order down. Okay, x1 equal to p2. Look at this is the collation we're focusing on. Okay, P2, P2, P4. Look at that. P2, P4, P3, P6, and P5. Okay, take a look at that. That is what we are. So if you want to consider order now, okay, we're talking about sequential collation is the order that the player votes in the collation. Okay, and if you want to talk about the order right now, you're actually going to say the one that comes first, followed by the second one, and so on like that. That's exactly what I put right here. Okay, now we keep a running total of vote for when a player joins to determine which player casts the winning vote. Now take a look at what we're going to do now. We're going to start from player number 1. Now let's go back to the collation. Look at this collation. What is the first player in this collation? That is P2, right? P2 is the first player. I'm going to start with player number 1, P2. Now look at P2. P2 has how many votes? Go back. Look at that. This is for P1. This is for P2. This is for P3. This is for P4. And this guy here is for P5. And this guy here is for P6. Take note of that. Okay, so we're going to start from P1. And P1, we're going to start from P2 because we're focusing on this. Okay, we don't consider P1 is the collation. Okay, now P2 has how many votes? 6 votes. Look at that. Can you see the 6 votes right now? Okay, it has a 6 votes. Take a look at that. Then the next thing that we're going to do, we're going to combine P2 with P4. Look at that. We started with P2. Don't forget, where are we actually going? This is where we're going. Give me 1 second. I'm going to tell you now where we're going. This is where we're going. Okay, that is the collation we're giving, right? And don't forget, in the collation we're giving, you have a P5 before P6. You have a P6 before P5. Look at that. P2, P4, P3, P6, P5. In that order. Don't rearrange that. That is the order, okay? P2, P4, P3, P6, P5. Now, if you want to start, you go to first start with P2. After starting with P2, the next thing is going to be P2 and P4. After P2 and P4, the next thing is going to be P2, P4, P3. Look at that. That's what I'm going to do. You're going to see now. Take a look at that. P2, P2 and P4, P2 and P4, P3, P2 and P4, P3, P6, and the last one. Look at that. Do you see that now? So easy that way. Look at the order. Started with the P2, then you now combine P4 with that, then you combine P3 with that, then we combine P6 with that, then until you get to the final one. This is the final one that we are anticipating, okay? That is the final one. Oh, can you give me 1 second? Give me 1 second. Okay, thanks for that. Now, if you consider P2 alone, then you're actually going to see that P2 does not have the votes, enough to win. So you can see the one that have the vote enough to win is actually this guy here. Take a look at that. And which means it is until we added P5, okay, you know, that they have enough to win, okay? Because of that, so player 5 is a pivotal player in the collation. Is there anyone who doesn't understand how to figure out a pivotal player? Is there anyone? Now player 5 is a pivotal player. So you got to do it in that order, the way you are given, okay, until you get to the one, the collation that actually give you a minimum number of votes required to pass to pass the proposal. Take a look at that. What are we anticipating? We are targeting 16. That is the minimum. Okay. Now, when you added P6, as at this side, when you added P6 to the collation, that give you 15. That is what give you the minimum required until P5 is added. Therefore, player 5 is a pivotal player, okay, in the collation. Okay, now, so what I'm trying to say, if there are 10 players in a voting system, how many sequential collation are there using all players in the voting system? Of course, right here, if there are 10 players, you're actually going to use factorial. Okay, it's going to be 10 factorial. You remember we did 10 factorial in class. I mean, we did factorial in class. Okay, so anytime you ask you to find sequential collation, of course, the number is actually going to be, do the factorial of what you are given. That's so easy to get. Okay, and that means you get 3,628,800 sequential collation can be formed. Okay, now consider the weighted voting system with this. We have 3 players with 7 minimum required. Okay, find the SSPI for each player in this system. Okay, so how do we find the SSPI? I'm actually going to show you now. Okay, I'm going to show you how you can actually get that now. Okay, now if you want to do that, the very first thing you're going to do, how many players do we have? We got 3 players. And what is going to be the number of sequential collation that you can form? It's going to be 3 factorial. So which means you're actually going to have 6 sequential collation containing all 3 players in the voting system. Okay, that is going to be the sequential collation. Now let us have the list. When I say 6, this is the 6. 1, 2, 3, 4, 5, 6. Okay, so that is a possible number of collation that you can actually have. Now, if you have that as a possible number of collation, okay, the next thing we actually want to do, for each of the collation, you need to determine a pivotal player. Okay, now what do I mean by pivotal player? Now take a look at this. You know, if you let's look at it. P1 has 4. Okay, we have 432. I'm going to tell you now. P1 has 4. P2 has 3. And P3 has 2. Okay, number of votes. Okay, and what is the minimum required? Let's see, 7. Okay, 7. 7 is a minimum required. Okay, 7 is a minimum required, right? Okay, now you're going to see something right now. Okay, I want to tell you the reason why our P2 is being referred to as pivotal right here. I'm going to tell you now. When I start with P, what is required? Minimum that's required is 7, right? To win a collation. Now, when I start with P1, in this arrangement, when I start with P1, okay, I'm actually going to have 4 votes. And that is not, that is less than 7 required, right? When I consider P2 with that, which means I'm going to add 3 to 4. When I add 3 to 4, that will give me 7. Therefore, the current player that I had, okay, that make up the minimum vote required is pivotal player. That is the reason why P2 is a pivotal player in that first collation. Now, in the second collation, when I have P1 and P3, when you add P1, 4, okay, to 2, that will give you 6. That is not up to 7 required until you added P2. Now that is the reason. Can you now see the reason why each of that is a pivotal in each of that? Because the moment you get to them, okay, you're actually going to get what you need, the minimum number of 7 that you need. Okay, take a look at that. Now, because of that, now the next thing you're now going to do is you're going to count the number of time a particular player is pivotal. Now, so here I said P1 equal to 3. Why do I say that? Look at that. 1, 2, 3. Okay, it means P1 occur 3 times as a pivotal player. Okay, P2 occur how many times? 1, 2, 3. That also occur 3 times too as a pivotal player. Take a look, and that is the reason why I write P1 equal to 3, P2 equal to 3, and let us see whether P3 is a pivotal. Let's see. Let's go back. Let's see whether P3 is a pivotal. We're going to see whether P3 is a pivotal. Oh my God, there is no any under this arrangement, any of this arrangement that P3 is a pivotal. Therefore, P3 is never a pivotal. Okay, that's why. So if P3 is not a pivotal, then P3 is a dummy player. You remember the other time I talked about dummy player? Okay, I talk about a player is a dummy if it is not pivotal. Okay, so therefore, P3 is not a pivotal. So the next thing you're actually going to do, then we're going to divide the number of time the player is a pivotal player by the total number of sequential collation. That's what we're going to do to get the SSPI that we're looking for. So the SSPI is different from the BASA. You remember we determined the Banzhaf Power Index the other time. That is different from this. Okay, now the denominator here is different. Look at that. Here you are using n factorial, but in the case of BASA, you are actually using it to total number of time. Players have been critical. You remember that? Okay. Now take a look at this now. So we're going to calculate this for each of the player. Okay, so when we do that, take a look at that for player one. It's pivotal 3 times, player two pivotal 3 times, and player three is never a pivotal. Then I'm actually going to find that would be 3 divided by what? 3 divided by 6. Because don't forget the possible collation is 3 factorial, which is 6. Okay, take a look at that. So player one contribute 50%, player two 50%, player three is 0%. Okay, and what you can see now, player one and player two have equal weight in the outcome of the votes in this voting system, and why player three has no influence. Take a look at that. Okay, so SSPI, the SSPI is called Shapley-Cubic Power Index for each player. And we actually use that to be able to evaluate, okay, how important a player is in the weighted voting system. Okay, how important a voter is in a weighted voting system. And the Shapley-Cubic Power Index will enable us to do that. I think somebody is talking, but the person is on mute. Uh, can I? Do you want to tell me something? I can say that somebody is talking right now, but the person is on mute. Okay. Can you guys confirm if you're hearing me clearly? Okay. Thank you for confirming that. Okay. So this is an example. You can determine SSPI for that for each player, and you can confirm that. Okay, confirm, because the answer here is saying all the players in this voting system, they are equally they have equal influence. Okay, 25%. So you can check out on that, because that could be a potential exam question. Okay, now I want to thank, is there anyone, because this is where I'm actually going to stop. Is there anyone who want to ask question or who need clarification? Is there anyone? I want to thank everyone for attending my lecture today. Of course, also want to appreciate everyone for the successful semester. And like I said, this is going to be the end of my lecture. And of course, for chapter 11, I'm actually going to record that and share the video with you. But you know what? The exam question will not cover up to chapter 11. Okay. Now, uh, I want to tell you that the final exam is actually going to be cumulative. And that will call across everything that we have done up to chapter 10. And of course, on Monday, I'm actually going to have a preview of the final exam. But before Monday, on Friday, tomorrow, I'm actually going to post final practice questions. Okay, I'm going to post final practice question, and I'm encouraging all of you. I want us to meet on Monday, and where I'm actually going to walk you through the final practice question. And like I said, the exam will be posted by 8 a.m. on on the 9th of December, the final exam. And of course, I'm actually going to leave that for 24 hours. Okay. And for those of you who have not completed assignments, please do so, because uh, we are in the process of you know completing your results. Now, uh, I've already updated all results, all aside for all assignment, the midterm one, midterm two. If you have not seen your results, some of you have been checking Ox Learning. That is the grade on the Ox Learning is not your grade. I want you to take note of that. Check the module. You're gonna, the grade on the module is your grade, not the one on the Ox Learning. I'm gonna say that again because some of you have reached out to me. The grade on the Ox Learning is not your grade, because I've already extracted your grade from Ox Learning and I've put that into the module. So check the module, and if there's any one of you who want to ask question, who need clarification on anything, you can reach out to me. Send a message to me. I've been meeting with people privately on Zoom. Okay, I can actually meet with you as well. If you have, the number of assignment you need is 10 out of 11 assignments. Okay, 10 assignments will go towards your final grade, the midterm one, the midterm two, and the final. Okay, okay, and I want to appreciate every one of you. Oh, you guys have been a very listening student, wonderful student that I've met. Although I believe because of the COVID, because of the pandemic, we have not been able to, uh, you know, socializing. But I believe the COVID is going to be defeated. Okay, I believe that we're going to socialize again. We're going to come together again because we need one another. And I'm using this opportunity to tell you, you are preparing for an exam now. Believe in yourself. Believe you can actually succeed, even though situations are not perfect right now. Even though I know some of the students, some of us are going through crisis, but believe you can get things done. Okay, believe in yourself. Believe in God. Believe you're actually going to be fine. Believe you're actually going to be successful against all odds. Okay? And I wish you very best of luck. I'm actually going to meet you too on Monday for the final practice questions. Okay? So, is there anyone that want to ask anything or you have a question?
Could I ask a question about chapter 9?
Okay, go ahead.
So I've been working on that one problem that has the negative exponent. And you know how I met with you and you said to do it 1 over and then the equation?
Okay.
So I did that, but it still gave me the wrong answer.
Okay, now you know what I want need you to do.
Mm-hmm.
Now, can you have a way? Can you screenshot what you want to do? Send it to me. I'm actually going to help you out. I'm going to respond to that. I'm going to write something down, and I'm going to forward that to you. Does that make sense?
Yeah. Mm-hmm.
Okay, so do
So
that
do you
and
want
send
me
that
to
to me.
send it to your email?
Exactly. Send it
Oh,
to my email.
okay. Thank you.
You welcome. I think a chat came in. Let me read my chat. None of my assignment grade are in module, and I've done them on. Oh, okay. I'm going to check. I'm so sorry about that. I don't know why I missed that. So I'm actually going to check. You know, you mean you've done all your assignment on Oxlani and I'm not able to pick that? Okay, I'm going to revisit that today. Okay, I can assure you, I'm actually going to see. I'm going to extract all of that today. Does that make sense to you now? Okay, so I will do that. So is there anyone that or the other one that have any other person that have question before I go away today? Is there any other one person? Okay, thank you so much for attending my lecture. Make sure you stay safe and have a good day, guys. Bye for now.